Hello Legacy students. Today we're going to look at cube root functions, what you're going to want to have on you, those notes I gave you in class, a pen or a pencil, probably a calculator but not needed exactly, and then you're going to want probably two colors so we can draw our original function and how it moved. So let's look at a cube root graph. So a cube root graph is going to look something like this, kind of like an S, really, it's an S, and some dots I want you to be kind of aware of. Cube root of 0, we know that to be 0, so that's this point right here, right in the middle. Kind of like the turnaround point, if you want to call it that. The cube root of 1 is just 1, so that's the dot right here. And then the cube root of -1. Now, a few of you have asked it before, I can't take a cube root of -1, that's going to be an I. Well, you can take if you have a negative underneath the radical and it is an odd power, aka 3 or 5, you can take that. So this is actually going to be -1. So that's the dot right here. So be aware of those three dots. So basically 0, 0, 1, 1, -1, -1. Your domain. So notice I'm covering all the negative x's and all the positive x's. So my domain is from -infinity to infinity. My range, getting all the negative y's, right? Because this is going to keep opening up and up, and this is going to open up this way too. So I'm getting -infinity to infinity for my range as well. What do we remember about shifting and square roots? So if you had something underneath, remember that went right because it's a negative. Outside the radical made you go up or down. The negative, if you remember, that flipped us or reflected us, so it went across the x-axis. And then this 2 on the outside, remember that kind of like changed our slope. We didn't call it a slope, but we kind of did because it changed the slope of that first dot there. And then this would go left 1 and down 3. Same thing is going to come out with a cube root graph. So if I have something on the outside, it's going to move it up or down. Something on the inside is going to move you left or right, and it's going to be opposite, like normal, when you think about it. So if it's a plus, it's going to move you left, and if it's a negative, you're going to move right. If you're going to have something outside that's going to vertically stretch or compress your graph, so that's like our slope. And then the negative is going to reflect you across the x-axis, or basically flip it. So let's take a look at an example here. So I have the cube root of x minus 2 plus 1. So this is going to move me right 2 and up 1. First of all, let's graph our original. So that's going to be a graph that looks something like that with those three dots. And then it's going to be, whoa, that's a little off there. It's going to be my S, like that, right? Okay, I'm going to change my graph color here. Let's graph this one. So these dots, I'm going to move them right 2, up 1. So I'm going to move the middle dot here. 1, 2, up 1. And then basically, since I don't have a change of slope at all, I'm going to go up 1 over 1 and down 1 over 1 to make my two other dots. Let's go ahead and draw in my new graph right there with the purple. So now, what's the domain of my purple graph? My purple graph is from -infinity to +infinity. It's kind of interesting. It didn't change my domain at all. What about my range? Well, this is going to keep opening up, right? So I'm going to go from -infinity, and it's going to keep opening up on this side. So +infinity for my range as well. That's kind of interesting that it didn't change. Let's see if that continues to happen. What about this one? So let's first draw in our regular graph. So that's going to be 0, 0, 1, 1, -1, 1. And I'm going to draw in my really sweet little looking S. There we go. That's actually a pretty dang good graph. Good job, Marsh. So this one now, it's going to move me left 5, right? Because it's a plus inside. And then I'm going to flip as well. So, let's move left 5. This dot, left 5. Right here. Now, we don't want it to look the same, right? We want it to look kind of like this to flip. So I'm going to go up 1, left 1, and down 1, right 1. So instead of being a positive slope, we're going to have a negative slope. Notice how if I would draw that line as a straight line, it's going to be a negative slope. Now to do my curve. There you go. That is my flipped and moved left 5 cube root graph. So what about my domain? Getting all my negative x's, getting all my positive x's. So my domain still has not changed. That's pretty interesting. My range, all the positive y's and all the negative y's. So same thing, domain and range, both negative infinity to infinity. Nothing has changed on either of those graphs. Let's try the last one here. So I have f of x equals 2 cube root of x plus 5 minus 1. So very first thing, let's graph in our regular. So it's going to be 0, 0, 1, 1, negative 1, 1. And we're going to draw in a nice little swoop like that. Alright, let me change color here. Let's go green. So this is going to change my slope, right? So my slope's now going to be up 2 over 1 instead of being up 1 over 1. Left 5 and down 1. Okay, so let's follow our directions to put our new middle dot. So left 5, down 1. It's going to be a graph right here, right? But now I'm not going to go up 1 over 1 because my slope is a little different, or my rate of change. So that's up 2 over 1. So I'm going to go up 2 over 1, put my dot. Down 2 over 1, put my dot. Then I'm going to draw in my nice and wonderful S. Just like that. So, my domain. Getting all my negative x's yet? And all my positive x's. So my domain is from negative infinity to infinity. My range, all the negative y's and all the positive y's. So every single graph we did today on this video had the same domain and range of negative infinity to infinity. And I'm going to give you a hint, guys. Cube root graphs will always have that for a domain and a range. So that's the easiest question I could ever ask you. Alright? So domain and range for all cube root graphs are negative infinity to infinity. And with that, that's the end of this video. See you later, Sabers.